All right, last one at least I have listed up here. So f of x equals x to the fourth plus 5x cubed minus 27x squared plus 31x minus 10. It says list all the rational zeros. The student did tell me that they wanted to know how to find all the zeros, and by using the guess and check method. And I haven't taught that in 5 years. Not that I can't do it. It's just I stopped teaching it because it took so much time. It was, in my opinion, as a teacher and for a student, it just wasn't a good use of our time in class, nor for students to really work through it, because we use graphing technology. So, I give this problem, or when we work on a problem like this, my students would have graphing technology. So, and plus, I want them to be able to find all the zeros. I'm not really concerned about them guessing and checking to figure out what they are. But I think if we do talk about the remainder theorem, we do talk about how to determine if something is a real zero. So let me kind of explain what we do. First of all, if I just want to find the list of real zeros, we're going to do the P over Q, which is called the rational zero test. Okay. So the list of rational zeros is plus or minus the factors of P over Q. So basically all you're going to do is you're going to take the factors of P, not negative, but just do plus or minus. So it's going to be plus or minus 10, plus or minus 5, plus or minus 2, and plus or minus 1. And you're going to take those all over the factors of Q, which thankfully for us is just plus or minus 1. So therefore, obviously, dividing by 1 is not going to change the factors. So therefore, our list of possible rational zeros, I'm going to put the plus or minus on the outside, is going to be 10, 5, 2, and 1. Now, how do we know if these are the list of possible rational zeros? How do we know if these are a rational zero or not? Well, what we can do is use the remainder theorem. If we plug in f of 1 and we get 0, then, let me do this, if f of 1 is equal to 0, then x equals 1 is a 0 of f of x. I don't know why you're giving me that time. Start that again. Of f of x. Batteries all right? Yeah. So basically what we would do in this case is you would list all the possible rational zeros. You plug in f of 1. So then you plug in 1 in for all of these x's. And if you get 0, well then guess what? You have a rational zero. Let's see if I can, and then you just move on. And then you say, all right, let's say 1 was not. Then you do negative 1, right? And then you do 2. And then you do negative 2. And you can just see how crazy this can get. Now, again, once you find a 0, then you're going to want to use synthetic division or long division. Let me see, actually, let me see if I can figure maybe 1 or negative 1. Let's see if I can do those in my head. So that would be 1 plus 5 minus 27 plus 31 minus 10. So that would be positive 21. Okay, so f of 1 does work. What about negative 1? That would be a 1 minus 5 minus 27. I don't think this is going to work. Minus 31. No, this is not going to work. All right, so negative 1 is not 1. So, but maybe 2 is, and I am not going to go through all this. But let's just do, let me show my work then for this, and I'll show you at least what the first step is. Because I would not, I just have my students graph these and be fine. But let's figure out, let's just confirm f of 1 real quick, and then I'll at least do the next step. F is 1 to the 4th plus 5 times 1 cubed minus 27 1 squared plus 31 times 1 minus 10. Right? So we get 1 plus 5 minus 27 plus 31 minus 10. And 6, that's 37. If I'm doing my math right, I'm getting 0. So therefore, now we know this is a 0. Now, what do you do with that? Well, again, you can use synthetic division, right? If you know you have a 0, then you can take that 0 on the outside, take all the coefficients of your polynomial. So that's going to be 1, 5, negative 27, 31. Make sure they're in order and make sure you're not missing any coefficients, and 10. If you're missing a coefficient, make sure you use a placeholder as 0. All right, and then you could do long division as well, but who wants to do long division for this problem? Because when you have just an integer, it's much easier to do synthetic division. So you bring another 1. And again, also, when we do synthetic division, what this is also going to do is also going to confirm that this is a 0. So 1 times 1 is 1. So that's going to, or wait, 1 times 1 is 1. So 5 plus 1 is 6. 6 times 1 is 6. Negative 21 plus 6 is going to be negative 27 plus 6 is negative 21. Negative 21 times 1 is a negative 21. That becomes a positive 10. 10 times 1 is a negative or a positive 10. All right, now let's go and see if this is factorable, right? And automatically I can tell that that's not going to be factorial, so that's the remainder, constant, linear, quadratic, and that's the cubic. So technically, I have one factor, right? X minus 1. And then my other factor here is x cubed plus x squared plus x plus 10, right? So what I did by doing this is I've just factored this down. Now, obviously, if this was factorable, right, by grouping, you could go ahead and just factor it. But it's not factored by grouping. So therefore, what you need to do is you need to find another 0. And you need to find another 0 and then do synthetic division again. But make sure you only do synthetic division with this answer here of 1, 6, negative 21, and 10. So I don't know what the other 0 is. I'm not going to go ahead and play guess and check for the rest of these. If it was me, I would just use graphing technology and figure out what real x-intercepted is. But if that's not available to you, then yeah, you're just going to have to plug in all these numbers. I always start with positive 1, then go to negative 1. Positive 2, negative 2. But again, we could spend all day. I mean, it could be negative 10, right? Would be the last one to guess. So just make sure once you find a 0 to get 0, use synthetic division to get that answer. Hopefully, if you already have another 0 or you need to find another 0, then you do synthetic division again with that 0. And then that answer will be a quadratic. And therefore, it's either going to be factorable or you can use the quadratic formula to find the remaining zeros. But just remember, by the fundamental theorem, you're going to have a total of 4 zeros, real or positive, real, imaginary, or irrational. So just make sure you're getting those to satisfy that.